So the proof really goes the same as for when we don't have the minus to the n here. The only difference is when we work out what the residue of this expression is at the poles of sec. So sec has poles at, sec is 1 over cos, so it has poles at z equals n plus a half. So we end up with, so okay, well I'll write this as cos pi z instead. Then this is our p, this is our q. We end up with substituting in f plus a half and differentiating the cos gives us minus pi sine pi z, sorry, pi n plus a half. Now this again we can write as minus 1 to the n. Notice that when n is 0, sine of pi by 2 is 1. When n is 1, sine of 3 pi by 2 is minus 1. Okay, so when n is even, we get plus 1. When n is odd, we get minus 1. So overall, we end up with minus times minus 1 to the n, f of n plus a half over pi, which is the same as when we had minus to the n with f of n rather than n plus a half, except for this extra minus sign, which is why we don't have a minus sign here.